Question says that establish the following vector inequalities geometrically or otherwise. So we have been given 4 vector inequalities and we have to express them geometrically or by any other ways. And also we have to say when does the equality of these 4 conditions will hold true. So let us take the first case where we have been given the vector addition. So let us find out the formula of vector addition. So let us assume that there are two vectors a plus b. So the vector addition magnitude can be expressed as under root of a vector a square plus vector b square plus 2 vector a vector b cos theta. Now let us pictorially represent this thing. So here the theta values cos theta ranges between -1 to 1. Now let us represent it with graph. So this is vector a, let us assume this is vector a and this vector b. So the addition would be somewhere like this, a vector plus b vector. Now the subtraction would be, if we invert this vector v, then we will get minus b vector. So this is minus b vector and this will represents a minus b. Now this relation is going to be true for both the cases. Let us make it with different color. Yeah. Now this relation is going to be good for this will hold good for both relation. Now the difference would be just in this sign a minus b. All that matters is the theta angle between them. So in the first case, vector addition case, we had theta as like this. This was vector a and this was vector b. This was theta. And in the second case, we have vector a and just inverted vector b. So now this is the theta. So moving on to the first question, we have the magnitude of vector a plus b, like this value, is always less than or equal to the independent magnitude of this vector a and vector b. So the magnitude of this expression relies all on cos theta value. So as we have said earlier, the cos theta is varies between -1 and 1. So let us say that when cos theta is -1, so the magnitude of vector a plus b is going to be equal to the independent vector a. It is -1, so it is going to be vector a minus vector b and when it is when cos theta is -1 and when cos theta is +1, we will have a plus b equal to under root of yeah. So we see that maximum value that it can have is this is the minimum value that it can have, and maximum value it can have is this. So as expressed in the first question, it says that it is going to be either less than or equal to this expression. So we can see clearly that the maximum value that it can have is this, when cos theta is equals to +1 or cos theta equals to 0 degree. So the equality sign will hold when theta equal to 0 degree, and in that case we will have this relation to be true, and minimum it can go is a minus b. Now the second question also says that the magnitude of vector addition of vectors a and b is always going to be greater than a minus b. So we see that minimum it can go is a minus b, the magnitude of a minus the difference in the magnitude of both the vectors. So minimum it can go is this one. So this relation is also true here. Now the equality will hold when when cos theta equals to -1 or theta equals to 180 degree, or uh, when both the vectors are in opposite direction. So here equality will hold when theta equals to 0 degree, and when theta equals to 180 degree, the equality will hold in second case. Moving on to the second part of the question, we have we have the vector subtraction a minus b, a minus b. Now we earlier saw that vector subtraction is nothing but the change in sign of the second vector, in this case the vector b. So vector subtraction is represented by this. Also we saw graphically the angle change in vector subtraction. So if theta is the angle between the vectors addition, then the angle between these two vector after subtraction would be, in subtraction would be theta equals to 180 degree minus theta. Now theta dash, let us say it is theta dash and it is theta. So the rule will work same like before this expression. Now the difference would be simply the magnitude of vector a minus vector b would now be expressed as magnitude of vector a square plus magnitude of vector b square plus 2 vector a magnitude vector b magnitude cos theta. Now here theta would be equal to 180 degree minus theta, theta dash, let us say theta 180 degree minus theta, because the angle has changed as we discussed here. So new angle would be 180 degree minus theta, and this would be the magnitude of vector a plus 2 vector a vector b. So cos 180 degree minus theta is going to be minus cos theta, so it is minus cos theta. Now this will turn out to be vector a magnitude minus vector b magnitude whole square. Now this will turn out to be vector a minus vector b. Now again it will represent it will matter if theta upon the value of theta. So if theta is equals to 0 degree, it is going to be this relation, and if theta is equals to -1, if theta equal to 180 degree, it is going to be the sign will change here, and it will turn out to be vector a plus vector b. So we saw from the previous case like that vector, if they both were both of the vectors were pointing in the same direction, or theta was 0, then the value was a plus b, and in this case the value is, when theta equals to 0, is a minus b. So the opposite equally we can say that the maximum value that vector a minus b can have is a plus b, or it will always be less than a plus b. So this condition we can say that the equality will hold when theta equals to 180 degree, because the maximum that it can have is a plus 1, else it is always going to be less than that, and the least that it can have is a minus b, which can be said that which can be clearly seen in the option D when theta equals to 0 degree, like in this case. So now we can conclude the question by saying that when vectors are pointing in the same direction, the addition of vector is equals to the magnitude of addition of vector is equal to the independent addition of the magnitude of the vectors. If vector is pointing in the opposite direction, then the magnitude of vector is equal to the difference of the magnitude of the independent vectors. Now if the vector is pointing opposite of each other, the magnitude of the difference of the vector is equal to the addition of the independent vectors magnitude. And this if the both of the vectors are pointing in the same direction, now the difference is going to be equal to the difference of the independent vectors if they are pointing in the same direction. Like